Hello, everybody. My name is Erik Alfaro, and today I have something pretty interesting to share. It's a presentation about a Think Aloud reading strategy, and this is a reading strategy that really changed my reading methods after I tried it, and it's pretty interesting. So let's dive right into it. So, what is the Think Aloud strategy? It's a reading strategy that is designed to help a person monitor their reading and thinking while they read the text. Usually, people read texts quickly and they try to absorb the information they read in one single shot. But for the most part, this method is problematic because you're not really spending too much time on the text and you're really just doing it for completion, which limits your ability to be able to comprehend the text. And it also limits your ability to learn the most out of your reading. So what Think Aloud does is that it's designed so that a person will more carefully read a text and make mental notes and connections with their life. So as you practice the Think Aloud strategy while reading a book or an essay, you will be reading more carefully and more slowly, and this is what allows you to make these mental connections. Say that you read something in a text that relates to some other book you read, or maybe you read something that relates to a movie. You can make those connections and be like, oh yeah, I remember this, and oh yeah, this is really fun. So, this is what Think Aloud is meant to do. And in addition to that, Think Aloud teaches students to reread a sentence, read ahead to clarify, and look for context clues to make sense of what they read. So, each of the Think Aloud strategies that we'll be discussing next are designed to help people be able to make these clarifying notes. Maybe there's something you didn't understand at first, but this strategy gives you that opportunity to be able to look up words that maybe you didn't understand, or maybe you just needed to give the text another read and everything makes sense. So, what is Think Aloud made up of? So, Think Aloud consists of these following 8 reading strategies. And I color coded these for easy viewability. And keep in mind, because these color codes will be relevant in the couple of slides that follow. So to start off, we have predicting. Pretty simple. All you do is predict what the text will be about. So you can say, I think that this reading will be about, let's just say it might be about algebra. So I think it'll be about variables, quadratic equations, linear equations, whatnot. So that's a prediction. Questioning. You can also question the text as you read because oftentimes there's new information that we are presented with in a new text. So we might have questions that we might want to look up or questions that might be good to keep in mind because the text might answer them later. So a good question could be, what is a variable? Visualizing. This strategy allows you to read a text and then make a mental picture of what the text is saying. So for example, if the text says, um, we are going to solve the equation y equals 3x. You might picture in your head the equation y equals 3x on a whiteboard, and then you might picture yourself solving the problem on that whiteboard and getting the answer. So that's an example of visualization. Personal response. This is probably the most common of the think aloud strategies, and this is pretty straightforward. All you do is make mental notes about what you think about the text. You can say, I liked this part of that the reading, or I think differently about this section of the reading. So that's what personal response has to do. It also has to do with your emotions. It could be like, oh, I feel happy about this part of the reading, or I feel upset about it. So that's your personal response. Clarifying. These can be questions or statements that you make about the text to help you clarify the meaning of the reading. So sometimes you might come across a new word or a new phrase that you don't understand. And say, for example, you have a logarithmic equation and it says logarithms in the reading. You might be like, what's a logarithm? I'm not sure what logarithm means. So you might note that, make a note that you want to clarify that later on. And oftentimes the reading does answer those clarifying questions for you, and then you can also mark that as clarifying. Summarizing, straightforward. All you do, you can summarize either portions of the text as you're reading along, or you can summarize the whole text at the end and just make notes about what was the most significant parts of the reading, what you liked about it, and what you feel is important to learn about it. Reflecting, one of the most useful strategies here. Sometimes you can just take a pause during the reading and be like, this is something that I didn't consider before, but I'm glad that this reading has presented it to me. So, for example, say you have the Gauss Jordan elimination method to solve matrices. That's something that you might have not considered before because usually when we solve systems of linear equations, we either do so by graphing or by algebraic methods. But the Gauss Jordan elimination method is actually a method that solves systems of linear equations using matrices. And at first, it does seem complex, but it does have a lot of use in daily life. So if you feel like a text kind of makes you reflect about your past experiences, or maybe you're learning something new, you can take the opportunity to reflect. And finally, making connections, either personal or text to text. So oftentimes you'll make connections between the text and your own life, or maybe you have read a book before and this new book that you're reading right now is related to that. So you can make those connections and you'll expand your learning. So for my practice, I chose an article called Nothing Matters: How the Invention of Zero Helped Create Modern Mathematics. It was published on September 20th, 2017. And in short, I'm gonna give you a brief summary of the article because in the next couple of slides, well, what we're gonna do is we're going to practice the think aloud strategy. I'll let you know how I broke it down, and I'll actually show you the paragraphs, the individual paragraphs of the article. But I'm not going to read the entire paragraphs because it would take too long. But I will give you a brief overview of my think aloud strategy. But in short, this article is a brief history about how zero got invented. And fun fact, for those who didn't know, the first known use of zero dates back to the 3rd or 4th century, and it's a dot that was inscribed on a piece of birch bark. And this is something that is attributed to the Indians, part of their culture. Pretty cool, right? Who could have known that? Who could have imagined that a dot would be the first known use of the number zero? But that's how it started. The article also talks about what zero symbolized. So, zero basically was a symbol created to mean nothing, to mean nothingness, that there's nothing of that left, that there's nothing of that remaining. This article also goes into the details of the challenges that existed to make zero a permanent part of mathematics because early on, there were a couple of philosophers. One of those was Parmenides, and Parmenides thought that if there was something to talk about in discourse, that there couldn't be such thing as nothing. So that was one of those challenges that made zero kind of hard to adapt into daily life. And the other challenge was that zero had a satanic connotation, which is not true at all. There's nothing evil about zero. It's just a symbol that means nothingness. That means it just means that there's nothing of that. And finally, the article talks about how zero influenced modern mathematics through the creation of algebra and calculus. And indeed, zero has also made calculations easy. For example, it's so easy to divide and multiply by 10, for example. And a lot of algebraic and calculus computations are much simpler to do with zero. So just from reading the title, you might remember the title of the article is Nothing Matters: How the Invention of Zero Helped Create Modern Mathematics. So just from reading that title, I predicted that I thought that the article would talk about the invention of zero and how this numerical concept came to form mathematics as we know today. That turned out to be true. I also predicted that the article would emphasize the importance of nothingness. We'll see that later on. I asked two questions. The first one was, what is the article's definition of modern mathematics? And why not title the article Contemporary Mathematics? Because the words modern and contemporary in history usually have different meanings. Modern usually refers to a time not in the distant past, but it usually refers to the era between the 1800s to about the 1950s or 1960s, around that time period. And contemporary refers to recent and current mathematics, so they could be from 1970s to present. So that's why I asked those questions. And I also asked, is the article's definition of modern mathematics meant to refer to current mathematics? So those were my two questions. And I also predicted that the article would give a definition of modern mathematics, whether it be implied or explicit. And I predicted that I would learn about why zero came to exist. And I also made a connection just from the title. So Think Aloud has a lot of benefits if you really practice it. And that connection I made was I like how this article relates to a poem that I wrote about math because in that poem I talked about the number zero. And that's true. If you look at my math poem section of the website, you'll realize that it actually has zero. So take a look. The first paragraph, if you want to read it, it's right there. But my responses using the Think Aloud strategy were a question, first of all. What was the Bakshali manuscript look like? And I tried to make a mental picture of that, and I said, my guess is that the Bakshali manuscript was a small piece of birch bark that looked like a sheet of paper and was whitish in color because birch wood, it's not like oak wood and spruce wood where it's like brownish. It's more like a whiter type, it's a whitish type of wood. So that's what kind of came across my mind. And at the same time, I made a connection that it reminded me of how ancient civilizations used papyrus at one time to write as a writing utensil. So that was pretty cool. Already, the Think Aloud strategy making wonders in my mind. I had some personal responses. The first one was that I thought it was weird how the small dot could represent zero because technically that one piece of dot is a single unit, right? So it could have been easy interpreted as the number one, but of course, a representation of zero had to start somewhere. So for the Indians, that meant inscribing a piece, just a single dot, and then probably for the Indians, the number one probably was like a tally mark for one or something. I don't know, but something like that probably. Reflection. As I read this first paragraph, I could see why my prediction about the article explaining the invention of zero was correct. So I reflected on my earlier prediction, turned out to be right, and so far, so good. A brief summary of this paragraph, just for a checking of my understanding, is that this paragraph was mainly about introducing the concept of zero and its origins. It described how the first known use of zero was a small dot inscribed on a piece of birch bark, something which dates back to the 3rd or 4th century. And if you read the first paragraph on your left and the yellow highlight, it should correlate. Second paragraph, my responses. I started off with a personal response. That was the first thing that came in my mind, was that I agreed that without zero, mathematics would be chaotic. It's hard to imagine what math would be like without zero nowadays. I don't think we could come up with a good example of equations or solutions to mathematical problems without the number zero. At first, and this is a clarification note I made for myself, at first I was confused by what a positional number system was. But after rereading the text, I understood that a positional number system referred to a number system that required a careful consideration of number placement. The article made this clear to me by using a decimal system as an example, since a number's position in a decimal can change the meaning of the number. So that clarified what positional number system meant for me. So I tried to make a visual as well to make sure I could understand it clearly. And my visual consisted of an example, and I pictured this on a whiteboard. Like, let's say I was writing this on a whiteboard, and I put two values, the number 0.40 and the number 0.04. These two values are not the same, and the placement of the 4 in this decimal number will mean that the number is either bigger or smaller. So in this example, 0.40 is larger. And in the other example, 0.04 is the smaller number. So as you can see, the positional number system is very important to consider in decimals, and the positioning of the zeros or any other digit will really make a difference. The last sentence in this paragraph was very clear and understandable. That was a personal response I had, and I also reflected in the same note here because I also felt that that very last sentence is exactly what it represented exactly what I thought of when the article referred to a positional number system. And then I made a prediction for what the next paragraph would be, which was that I thought the article would start to focus on how zero has influenced math since its invention. Next paragraph, my responses. I had three personal responses. The first one was that my prediction wasn't exactly right, but I did still think that the article would eventually focus on the influence on zero on modern math. I also said that yes, we did go without using zero for a long time, and it's impressive how humans made it so far without serious complications. Of course, they probably had their own uh, verbal language or body language that was like equally representative of nothingness, but I feel like with the invention, since the invention of zero, things are a lot more simple. And also, I thought that Sumerians had an idea of what zero could be, because you can see in the paragraph that as early as 5000 BC, they already had their own positional system, and in some rudimentary form, they had like a placeholder symbol for zero. So I thought that was pretty impressive, but they just didn't know what to call that placeholder symbol or how to symbolize it. Here's a visualization again, trying to think about how the Sumerians might have represented the number zero. So I visualized that whenever the Sumerians wanted to create a number such as 2004, they would write the 2, their symbol for 2, and then they would use some unknown symbol as a placeholder for 0, and then write the 4. So to them, 2004 might have looked like 2 star star 4 or something similar. I also made a question. I wonder how they managed to make the difference between 5 and 500 clear if the placeholder symbol for 0 was never used at the end of a number. You can see that in the paragraph. So here was my clarifying notes, and my own guess to respond to that question was that the Sumerians probably had to use verbal expressions to clarify the numbers, or they had an established context that made it easy for them to tell apart 5 from 500, or the number 7 from 710, and so on. And another summary of the article just to check my understanding as I go here. So far, this article has explained zero's origins and provided early examples of civilizations that have used the concept of zero without knowing what to call it. Fourth paragraph, our responses were both a question and a personal response in the first note. So I started off by asking, why did it take so long to invent a clear symbol and definition of zero? And my personal response was, the benefits are obvious. And my guess is that people didn't know what to call zero, and they didn't know what to symbolize it as. And obviously, they didn't know these two things. They couldn't really figure out its mechanics until later on. Then I also had another personal response. Zero does make multiplying and dividing by 10 very easy, as I talked about earlier. I reflected on this note, and I said that I've been able to do so since elementary school, and I made the connection that I remembered when I first learned my times tables and division, that the easiest math I could perform back then was multiplication and division by 10. Think aloud strategy doing its charm here. I really recommend it. I also asked another question. Could algebra and calculus have been invented without zero? And my personal response was, I think they could have, but the current math system would be very complicated. I made another connection. The mention of calculus at the end of the paragraph reminded me of my research project on Gottfried Wilhelm Leibniz, because he also did extensive work in that field. And if you look at my mathematician biography video on this website, you'll be able to see more information about Leibniz's contributions to calculus. And I made a new prediction here. For the next paragraph, I thought that the article would go into dealing with some of the achievements zero has allowed for. Fifth paragraph, my responses. I started off with a new question, and that was, what were some of the mystical powers of language that Western philosophy concerned with? And a clarifying note for later consideration was that I was a bit unsure about the meaning of mystical powers of language, because if you look at the paragraph, it says exactly that. So that's something that I plan to research on later on, but it's not necessarily needed for the context of this article. It's just more like a fun fact. A personal response? It makes sense that the concept of zero could partly have been invented to reflect cultural values of nothingness. Another question I had was, what were some of the misconceptions of nothingness, and did zero help to solve these misconceptions? My personal response to that question was Parmenides, which was a Greek philosopher and thinker. He made things confusing by arguing that the idea of nothing could not simply be, and I mentioned this earlier on. And the clarifying note I added to that was that I get where Parmenides came from because it made sense. His argument made sense to an extent that if there was something to talk about in discourse, there could not be nothing. But my reflection on that was that his argument had some significant flaws because just because something is a matter of discourse, it's not exactly representative of nothingness. It's a separate concept. So really, the idea of zero talks about how there's nothing of an object or there's nothing of this material. So for example, say I had 5 apples and I ate those 5 apples. What am I left with? Zero. Zilch. I have 0 apples. I can't say that I have some apples if there's clearly nothing. So that was one of the flaws of Parmenides' argument. And another response to that was that I suppose the Parmenides' argument was indeed a grave misconception about nothingness. So this also helped clarify my earlier question about what were some of the misconceptions of nothingness. Sixth paragraph. So you can see here, here's the note I made about how some people in religious affiliations labeled zero as satanic. But that was an incorrect label because, like I've been explaining, zero is just a mathematical term that means that there is none of that item or none of that remaining. I made a connection here because this paragraph talked about how the merchants continued to secretly use zero because it was actually banned for some time. And that reminded me of what would happen during the 1930s when the United States had an alcohol prohibition. You might remember this if you study history, that during the 1930s, they had a temporary restriction on alcohol. It was banned from use, but in spite of the ban, there were secret clans and secret clubs that would still make beers and alcoholic drinks. So that was a connection I made. And a summary for checking my understanding at this point of the article. The article has talked about how zero came to existence. It has talked about how it has made math easier and how it's come to develop algebra and calculus. And the article has also talked about some of the misconceptions of zero that caused it to be eliminated almost. Seventh paragraph. My personal response to it was interesting how the Buddhists consider zero to have a lot of worth. So in a way, zero's concept of being nothing actually means something. Not to sound contradictory, but it's very funny to think of it this way, but that's how the Buddhists go about it. Now, I'm not a Buddhist, so I don't know what nirvana is about or what it means. So that's a clarifying note that will be for further research. I also asked the question. It's not really in a question format, but my thought there was that this also makes me wonder how the Buddhists specifically made use of zero for their activities, which comes across as a question. And that's for further research. A personal response: I agree with the article's author that a mathematical symbol for nothing, like zero, has no negative connotations at all, because it just means that there's nothing. A clarifying note there was that it was interesting to learn that zero was derived from the Hindi word for sunyata, meaning nothingness. So that's very cool to know, and it makes good sense. I made a new prediction that the article would probably start to discuss zero's prominence in modern mathematics in the next paragraph. Here's the eighth paragraph, along with a quote by Fibonacci, who is a mathematician philosopher. And he wrote about the decimal system in Europe that the method of the Indians surpassed any known method to compute. It is a marvelous method. They do their computations using 9 figures and the symbol zero. Here are my responses. I asked the question at first. Why did it take so long for zero to become part of mathematics in Europe? 1,000 years was a long wait. Also, another response I had was, at least China and the Middle East adopted zero much quicker. I asked another question though, which is how long did it take for zero to arrive in America? Because if we're going to talk about zero's arrival to Europe and Asia, we might as well let's consider America because Well, for one, I live in America, and a lot of us live in America, but that is a question for further research. It's not necessary for the current context of the article. Fibonacci's comment about how the Indians did impressive computations with 9 figures and the symbol 0 is cool to read, my personal response. And the clarifying note I made is that I assumed that the 9 figures that Fibonacci referred to were the symbols for the numbers 1 through 9, and of course the number 0. And in the final paragraph of the article, my responses were that it was good to know that 0 helped make calculations very easy and allowed for further exploration and development in mathematics. I also thought that I'm sure that 0 has helped mathematicians like Leibniz develop their theories as well as various subfields of math like calculus and differential equations. So that was a personal and connection that I made to things that I've learned so far in math. And a final personal response and reflection was that to have a mathematician like Brahmagupta using 0 as early as the 7th century to develop modern algebra is quite impressive. It is quite interesting to learn how important 0 was in making mathematics the field we know today. And then these are my final thoughts after reading the article. I reflected on this article and I said that the article made really good sense, and I now have a clear conception of what 0 means and why its invention helped advance the world. I also felt that this article made me consider the importance of math concepts, and even though stuff that seems basic like 0 has a very interesting history and very interesting meanings behind it. So it's very important and cool to learn about this stuff. And I wrote a final summary of the article. I'm not going to read it because I already did kind of provide a summary, but you can take a look at that note I made at the end of the article. And I also made a clarifying note at the end, and that was that before reading the article, I always assumed that 0 was something that existed ever since the first humans were born. I was partially wrong because although humans have always had some way of representing 0 or nothingness, the symbol which we now recognize as 0 did not actually exist until at least the 3rd century. And here are the results of all the mental notes I made using the Think Aloud strategy. So I made a total of 7 predictions, 11 questions, 3 visualizations, 23 personal responses, 10 clarifications, 4 summarizations, 8 reflections, and 6 connections. The results will vary per person, of course. Everybody thinks differently, everybody makes different notes. So just because you see these results from my Think Aloud strategy doesn't mean that it's representative of everybody's expectations. And don't be afraid of making so many personal responses. You might be like, oh, maybe I didn't make so much of this notes, or maybe I didn't do this type of reflection. Do not worry. It's all about what you considered most important to you. And what matters is that you make the Think Aloud strategy work for you. So you use the strategies that you feel will help you get the best out of your reading experience and will help you get the best learning. And for me, making personal responses is probably the most helpful strategy. But of course, the other strategies were pretty helpful as well. And in conclusion, I think that the Think Aloud strategy helped me a whole lot with understanding the article. If I had read the article like I normally had, I would have spent less time making meaningful connections with the text and less time reflecting on what I learned. So, what I normally do when I read something, I just try to read it fast and try to cram as much information as I can in the get go. But that doesn't really work too well. So, Think Aloud helped me slow down my pace, and that slowness helped me really consider the information I was reading. And as you can see through this entire presentation, I really learned a lot, and I really felt that this was helpful to me. Using Think Aloud gave me an excellent understanding of what I read, while giving me the opportunity to connect 0 with certain aspects of my life. And 0 is really easy to understand. This is a pretty straightforward concept. I think many people will relate to it. Obviously, we use it in daily life. So there you go, folks. Thank you very much for listening. Give Think Aloud a try. The next time you read something, I'm sure you're going to find it very beneficial. And if you're worried about timing, sometimes people have like a limited time to read. I get that, but I still think that to an extent you can practice some of the Think Aloud strategies. Just try to give it a little bit of a slower read. Reread the text if you don't understand something, and make these notes. You can even highlight the text and be like, oh, yeah, this is a visualization I had, or this is something I connected with. Give it a try. I think you'll really like it, and it will really be helpful, especially for academic scholars or students in university. It will really help you. So that is my presentation on Think Aloud. Thank you very much for watching, and I hope you will be a very successful scholar, learner, and reader. Bye bye.